So finally we're going to estimate a neural network on one of the most famous data sets in classification, which is the iris dataset. It consists of 3 different flowers with information about width and length. In the notebook I describe how you do this manually and then upload it onto the Jupyter Lab. But here I'm going to do it directly, specifying the URL and then saving the data directly into a subdirectory data. So if you run this yourself, make sure that this subdirectory data exists, because otherwise your operating system may throw an error. So I run this code, so the data is now available. In the notebook we use NumPy to work with this data and normalize it and things like that. So here, to do it slightly differently, I'm actually going to use pandas. So I'm going to define iris data, and then I'm going to use pandas read a CSV file. Data iris. So that's the same file that we specify here. And I've used the information on the website to know what the names of the columns are. So that's length. Whoops. Width. Then we get length, and also here we have width, and then the last column is actually the name of the flower. So we can read this data, and then we can look at iris data head to get a sense what it looks like. So I have 4 columns with information. So these are the features of the flowers, and then I have the name of the flower. And the goal of the exercise is to use these features, so length and width, to predict the name of the flower. Now, working here with this name is not particularly useful when we want to do the estimation, so it's easier to actually turn this into 0, 1, 2. So there are 3 different flowers, and it's easier to work with if we have a variable which is 0, 1, 2. So I'm going to define a mapping. So the first flower is, and I want to map that into a 0. The second, I want to map that into a 1. And then finally, will be mapped into a 2. So then I'm going to add iris data, a new column called target. And that's going to be equal to iris data name replace, and then use the mapping that we just defined to replace it. And then we're going to move to iris data dot value. So I'm going to turn this into a NumPy array. So I want to have all the rows. and I want to have the first 4 columns, so that's the length and the width. And then just to be sure, so I want to use these as type float. I don't want them as strings. And then our targets is going to be iris data dot values, and again I want to have all the rows. I want to have the final column, which is the last column that I added, and that is going to be an integer. And just to be sure, what is the length of the target? So how many observations do we have? We have 150 observations. So then what we're going to do is to normalize the data that we have. So for the neural network, it's important that variables are between 0 and 1. So the way we're going to do that is first, I'm going to take the iris data that we have, and I'm going to subtract iris dot mean, and the mean I'm going to take along the rows. So I specify x is equal to 0, so that means I'm going to get 4 means. And then I'm going to define the normalization factor, which is the highest value that I can find along each row, and I'm looking at the absolute numbers along the row. So this part is the absolute value, so I'm using NumPy from the NumPy library, the function abs, which gives me the absolute value. So each entry is now turned into a positive number, and then again along the rows I want to know what the maximum is. So now I have my normalization factor, and that means that now I can write that my data is going to be this divided by the normalization. Yes, you can check for yourself. After this step, we cannot find values bigger than 1 or smaller than -1 in our data. Then we're going to plot the data, and it's nice to plot the different flowers with a different color. So I'm going to create this array with colors. So R for red, B for blue, and then G for green. And we're going to apply targets. So the vector targets consists of is a vector with either a 0, a 1, or a 2. So if the target is a 0, so it's the first flower, it picks index 0, so the color will be red. If targets is 2, so that's the third flower, it will pick the third item in this list, which has index 2, so then that will be green. So now let's have a first look at what our data actually looks like. So plt scatter. So I'm going to look at all the rows. Then I'm going to look at all the rows for the second feature. Oops, that should be a comma. Yeah, so this is all the rows and the first column, so that's the first feature, so that was a length or a width. And then here, again, all the rows, but now the second feature. And C is going to be colors. So this is what the data looks like. Yeah, so basically what we're going to do is we're going to use these features. So this is the feature in the first column, this is the feature in the second column, and we're going to use these features to separate these points. So I want to separate the red points from the blue and the green ones. Now here we can do this in 2 dimensions, and you can also check the other one. So you can change this into a 2 and then this one into a 3. Yeah, so here it seems easier to find a line so to separate these points, but of course we're not doing this in 2 dimensions, we're going to use 4 dimensions for this, because we're going to use all the features. So in 4-dimensional space, we're going to try and find a line such that we can separate these 3 flowers. So we can separate the different colors. Yeah, so in the next video we're going to separate our data, split our data into a train and a test set, and then we're going to estimate it in a neural network and see whether indeed we can separate these 3 flowers based on the information that we have in the features.